I'm Summers, a developer relations engineer at Google.
And I'm André, Android product manager focused on widgets. Thanks for taking the time to join us. We're excited to be here with you to talk about widgets. Nice, thank you. We're going to start by covering the value of Android widgets and demonstrate how to build great widgets using Jetpack Glance, a framework built on top of Compose for writing widgets. We'll cover the fundamentals of widgets, like what they are, how people use them, and why you should consider building one for your app. Then we'll discuss what makes a high-quality widget and how to build one using Jetpack Glance. First, let's cover the basics, like what is a widget? A widget is a piece of your app UI that can be rendered remotely outside the main Android application. Most commonly, this is the home screen, but widgets may also be displayed by personal assistants, rendered on lock screens, or other screens depending on the phone manufacturer. Widgets can be a powerful tool for engaging users and increasing the visibility of your app. They can also help you to improve the user experience by providing users with a more convenient way to access your app's content and features. If you're not already using widgets, I encourage you to start thinking about it. Here are a few reasons I think you should care about widgets. Widgets can help to increase the visibility of your app by placing your brand and functionality front and center on your user's home screen. Widgets can also help to improve user engagement by making it easier for users to access your app's features. And widgets can be a great part of your conversion strategy by recommending personalized content or premium features. Why widgets? People use widgets for so many different reasons. Let's chat through a few of them and how you might assess if building a widget is beneficial for your app. Users take advantage of widgets to customize their home screens, to make them feel more personal and unique to them, which tends to increase engagement. Consider how users might want to customize their home screen with content from your app. For example, the Notion widget gives users the ability to pin information that's most helpful to them, personalizing how they engage with Notion's features. Some users choose widgets because they enable access to frequently used features more efficiently and with less taps. Think about it for a second. Does your app have features that your users might want to jump directly into or even complete right from their home screen? One of my personal favorites is the Google Calendar widget, which allows me to view my day, realize that I'm late for a meeting, and jump right into the video call without leaving the widget. Certain widgets are most helpful without any interaction at all. Some of the most popular widgets offer a subset of information in a layout that can be consumed glanceably. If users are often launching your app just for a few seconds to get a status or a specific piece of information, this might be a sign your users would benefit from a glanceable widget. The Strava widget is a great example of providing fitness enthusiasts with the information they care most about at a glance throughout their day. Convinced that widgets are awesome? I already was. Great, yes. If you're going to build a widget, make it great. Here are a few tips for designing great widgets. Make sure your widget is helpful and relevant. Users should be able to get something valuable from your widget without having to open your app. Keep your widget simple and easy to use. People shouldn't have to spend a lot of time figuring out how to use your widget. Consider widget adaptivity. Ensure your widget works properly across the Android ecosystem of phones, tablets, and foldables. Make sure your widget is visually cohesive. And what I mean by this is users are more likely to use a widget that looks good and matches the overall design of their home screen. So take advantage of system color palettes, typefaces, and corner radii to ensure your widget is complementary to the system UI. And help users discover your great new widget. Prompt the user to add the widget from inside your app using our widget pinning API. And don't forget to include high-quality previews and descriptions so users can understand the value of your widget even before trying it. Before Summers walks us through how to implement a widget, I want to tell you a bit about some new resources we're providing to make building great widgets less complex, less time-consuming, and more integrated into your existing toolchain. First, there's Jetpack Glance 1.1. It has improved unit testing capabilities and the introduction of components that take some of the work out of building foundational UI elements. We've also released canonical widget layouts, which build on top of the Jetpack Glance components to allow you to get started faster with a set of layouts that align with best practice. They're adaptive across phone, tablet, and foldable. They're refined and they're customizable. These layouts will help you create engaging, productivity-enhancing widgets. The first set of layouts are delivered as code samples and a matching Figma library in the Android UI kit, with more layouts coming soon. To get started, first you identify your core content and you map it to one of the pre-built layouts to streamline the process. Let's have a quick look at the widget canonical layouts. Text layouts are ideal for displaying concise information. You can enhance the visual appeal of your widget by optionally including an image alongside the text. Use list layouts to organize multiple items into a clear, scannable format. This is ideal for news headlines, to-do lists, or inboxes. Choose between containerized or containerless presentation based on your content or branding needs. And grid layouts allow you to present images in a compact, flexible, visually rich grid. You can also incorporate text labels and descriptions, enriching the image grid content with additional context. Also, check out our latest widget design guidance to learn about building a best practice widget and up-leveling your app experience. Many of the examples you'll see on the new design site were created with the canonical widget layouts, and you can check it out on developer.android.com. Now over to Summers to walk us through the technical side of widgets.
So what are widgets from a technical perspective? Widgets are a special type of view that is shown inside of a host app instead of your main app, and they receive periodic updates. In this section, we'll go into more detail about what is required by your applications and the Android OS to support these special views and the limitations that are unique to widgets when compared to an app. Several basic components are used to create app widgets. First, the app widget host is an app that embeds a widget in its UI. This is typically the home screen, but it is not required to be one. There's also the app widget provider info, which describes the widget metadata, such as its layout, size, update frequency, configuration class, and so on. This is an XML file provided to the app widget provider. Finally, the app widget provider is a broadcast receiver that processes messages from the Android OS when the widget is updated, enabled, disabled, or deleted from the app widget host. It defines the methods that let you programmatically interface with the widget and is responsible for providing the widget's layouts to the widget's host. App widget layouts are written using remote views. These are special view classes that can be displayed in separate processes. Because they are displayed in separate processes, remote views have their own APIs, which are separate from the APIs of application view objects you are already familiar with. These pieces are associated together in your app's Android manifest.xml file. The widget's app widget provider is declared as a broadcast receiver, and app widget provider info is referenced using metadata. Once you've configured these components, your widget is ready to be added to a user's home screen. Widgets are added using the widget picker, pinned to the home screen from your application, or they can be added from a shortcut on your app icon. After you've defined an app widget and your user has added it to your home screen, your application is responsible for periodically updating the widget. Additionally, the Android operating system may also request that your widget be updated. Now that we've established a high-level overview of widgets in Android, let's discuss Jetpack Glance and how it builds on the foundation to let you develop widgets. So, what is Glance? Jetpack Glance is Google's recommended way to write new widgets. It is built on the Jetpack Compose runtime, allowing you to take advantage of Compose's benefits, such as writing declarative UIs with less code, using intuitive APIs, and writing and designing widgets using Kotlin instead of XML. Glance supports and builds on top of the components of a widget and inherits the same setup and configuration. Glance provides its own app widget provider class, Glamp app widget receiver. It uses a Glance app widget implementation to provide remote views to the app widget host. Creating widgets with Glance is done using Kotlin and Compose patterns without XML layout files. Glance widgets extend the Glance app widget class and override the function provide glance. This function is where you allocate any resources your widget needs. Then you will call provide content with the widget's Glance composables as an input. Provide Glance is called by the Glance library, and it is run inside of a worker. Glance provides components to display, utilities that help integrate with your user's theme, layouts that resize dynamically, and much more. This all comes together to make your widgets look amazing while still being easy to code. Glance's composables are wrappers around remote view objects and cannot be used alongside Compose's composables. When you're using Glance, be sure to only import composables from the androidx.glance namespace. Once a Glance app widget is written and placed on a user's home screen, it becomes your application's responsibility to update it. Glance provides update and update all functions, making updating widgets easy. These are suspend functions that can be called from any part of your application. When they are called, Glance will use the work manager to call your provide Glance function inside of a worker. This worker is subject to the typical worker time limit of about 10 minutes. Once your provide Glance method is called, provide content, composition will run for about 45 seconds. UI interactions and update requests cause Glance to add time to this limit. Glance will only have one widget per worker. When your application updates widget data, it should always call one of these update functions. In your widget's composables, you should always observe data sources from a flow or simmerable observable. This ensures that your widget will not miss data changes. Now that we know what Glance is and how it works with widgets, let's actually use Glance to build a widget. To do this, we need to add Glance to our project, extend the Glance app widget class, extend the Glance app widget receiver class, create an app widget provider info XML file, and reference all of these together in our Android manifest. The Glance dependencies are available in Google's Maven repository and can be included by adding them to your application's build.gradle file. For this project, we are using the release candidate version 1.1.0. We will include Glance app widget and Glance material 3 modules. After adding these dependencies, you will have to resync your Gradle project in Android Studio, and then you will be ready to use Glance. To implement a Glance app widget, extend the abstract class Glance app widget and implement the provide Glance method. In this method, you should provide your composables with the provide content method. In this sample, we can simply call provide content with our one text composable. I want to call attention to the namespace of the text composable class. This is a Glance text composable and not a Material 3 text composable from Jetpack Compose. Next, let's extend Glance app widget receiver. This class is an extension of app widget provider that uses our widget to generate views when needed. Glance app widget receiver implementations are required to provide a value for the Glance app widget property. This should be a no arguments constructor of your Glance app widget class. The final resource we must create is our app widget provider info XML file. This file is placed in our project's XML resources directory and is referenced in a receiver entry in your Android manifest. For our widget, we will be using an initial layout provided by Glance, allow resizing, configure our size constraints, and set up a refresh period. Our application can always refresh our widget outside of this refresh period as well. We can now add our widget to our Android manifest and display it on our home screen. This is as easy as configuring a broadcast receiver for our Glance app widget receiver, exporting it, and filtering on the app widget update action. We also pass in our widget's app widget provider information using metadata. This metadata is consumed by the app widget provider superclass we mentioned in part 2. After we build and run our project, we can now add the widget to our home screen. Now that we've added our widget to our home screen, we can see it as a beautiful baby hello world. Truthfully, it's not that beautiful. but we're on our way. In the next session, we'll add some structure, branding, interactivity to our widget. We want a high-quality experience for our users, and we can build it in Glance. High-quality widgets are ones that have a well-defined shape, integrate with the user's theming, gracefully resize, provide representative previews in the widget picker, provide fresh and short content, and have minimal and relevant controls. After this talk, you should take a look at our new widget design guidance and widget design hub that André mentioned before. These resources will build on the practical examples we're about to talk about and provide you and your teams with the necessary information to make widgets that look great. Glance 1.1.0 has been designed to support this guidance. Let's return to our Hello World widget. Glance 1.1.0 has a set of components that can be used to make sure that our widget looks good, resizes well, and behaves appropriately. Here, we've added a Glance scaffold component to our Hello World widget. A scaffold will display a title bar and our content inside of a padded frame. Scaffold's title bar property is filled using a title bar component. We've also given the title bar an icon and a title, and overridden the background color property to use the surface color token. As we see, this is a lot better than it was looking before, but when we compare our widget to other widgets, the colors seem off. On home screens, it is expected that widgets will set their colors based on the user's theme settings. Let's update our scaffold's background color to use the widget background color token. This is the default background color token for scaffold in Glance 1.1.0, but should be set if you're using different root composables in your widget. We should also use the on-surface color token for our content's text color property. These tokens ensure that our widgets fit users' themes and have the right contrast ratios. Now our widget matches multiple user themes, and it matches the themes of other elements on the home screen, including the wallpaper, themed app icons, and even other widgets. When you're writing your widget, be sure to test it using different backgrounds, sizes, and layouts. Always remember that you can limit the sizes of your widget display by setting the different size properties in your app widget provider info XML file. You can also find more sizing guidelines on developer.android.com's widget design guidance. In addition to our widget components and design guidelines, Glance has canonical layout samples in our platform catalog samples repository on GitHub. These layouts provide ready-to-go implementations of responsive, resizable layouts for many different use cases and widgets. Feel free to take a look, give them a try out, and use them in your project. Let's take some more time to talk about the architecture of a widget. Most widgets will have some kind of state information that needs to be initialized and configured, modified, and updated. Additionally, data may be loaded, or your widget may be in an error state. In this section, we'll demonstrate how to manage your widget in your application and how to handle these individual states. When a widget is added to the home screen, it is usually best to have some sort of zero state. This state prompts a user to configure the widget. It can either be a shortcut into the application or provide the configuration interface itself. Instead of displaying a simple hello world message, our widget should instead display a customized greeting with the user's name. In this example, our widget reads its state from a repository. When the state is empty, it should prompt the user to add a name. We will use the button component and an action created by Glance's action start activity method to do this. This action will call our configuration activity and provide the widget's ID as a parameter. This can be the same activity your widget uses for configuration. Developer.android.com has more details about configuration activities. Creating a zero state has an implied dependency on being able to read and write some kind of state from the application. This state should be managed using a repository object. When modifying the state, be sure to call the app widget's update method. Reading the state should be done through an observable value. Because the update methods are suspend functions, we recommend launching them outside of the main thread scope. In this example, they are launched from a repository. Glance also supports recomposition while the Glance worker is running. Since only one Glance worker per ID is running, Glance widgets should observe data sources within the composition to ensure that updates are not missed. There's more to making a high-quality widget than just a good design, displaying relevant and timely information. We also have a responsibility to our users to gracefully handle errors and provide users a way to recover. In Glance 1.1.0, we have updated the look of our default error layout and provided a new API to call in the case of a composition failure. This API lets you add a custom remote view layout to your widget to be displayed when there's an unhandled error. Additionally, you can override on-composition error in your Glance app widget class to configure action handlers in your error view. This should be used to provide users with the ability to recover the error state or information about the error that occurred. Glance 1.1.0 also has new testing APIs. These are available in the Glance testing and Glance app widget testing modules. These APIs bring a more Compose-style options for writing unit tests. These APIs give you options for testing without needing to set up data sources or a device. And with that, I hope you've gotten an appetite for building high-quality, helpful, and engaging widgets using Jetpack Glance. I'll hand it back to André for the conclusion.
Thanks, Summers. Incorporating widgets into your roadmap can offer a range of benefits. Widgets can boost your app's success by increasing visibility, user engagement, and conversions. Widgets also give your users the option to keep your app content visible and provide convenient access to features that may enhance user retention and satisfaction of your app. We encourage you to embrace widgets as part of your Android app strategy and check out our new widget design site for inspiration and getting started with canonical widget layouts. We're excited to see the widgets that you'll build. Thank you.